So still we have 2 days time. We can revise that particular topic or particular practical. Okay. So today we have to discuss about advanced switching. In advanced switching, we have to do ISP redundancy. ISP redundancy we can achieve with the help of FHRP protocol, first hop redundancy protocol. After that, we will implement switch port security. Once the switch port security is done, then there is a monitoring, switch monitoring. In the switch monitoring, we have to discuss about SPAN, switch port analyzer. So those will be the topic into the switching. Once switching is done, then we'll discuss about WAN. In the WAN, we have to discuss about the WAN technology, like lease line, frame relay, MPLS, the basic introduction to the VPN, like that. Then we have to discuss about TPP and HDLC, which is the two encapsulation protocol on the WAN. Then we'll discuss about the GRE tunnel. We have to discuss the GRE tunnel, and we have to see the configuration of GRE, generic routing encapsulation. Once GRE is done, then next topic will be the IPv6. IPv6 will do tomorrow, and the basic introduction to the QoS and licensing part. These are the topics which are pending into the CCNA right now. So we'll try to do all the things till tomorrow lunch, so that the next session will be the exam preparation. So that I will tell you like what kind of question will come, how the question format will be, and how to clear the exam. Any question? Okay. So the next topic is understanding layer 3 redundancy. Layer 3 redundancy means, let us assume you have two service provider for your network, and you want redundancy in the ISP. This is my internal network. These are my two ISP. Let's say ISP 1, ISP 2. They are connecting to the external world. In my inside network, we have a network 192.168.1.0/24. This is my private network. If I put here default gateway as this, let's say .1. So what will happen? Every time my traffic will forward to this ISP. And after that, this ISP will forward that traffic to the external world. But if this link goes down, in that case, the traffic will not shift to the ISP2. Why? Because you manually put default gateway is .1. And the same case, if you put here 2, in that case, traffic will shift to the ISP2 and it will forward traffic to the external world. But if this link goes down, again the same problem will be there. So if you are putting manually physical IP address of the ISP as a default gateway, in that case you will not achieve ISP redundancy. Clear this point? So to achieve ISP redundancy, we have FHRP protocols. FHRP is First Hop Redundancy Protocol. First Hop Redundancy Protocol. And FHRP is a category of protocol. Under FHRP, we have 3 protocols. One is HSRP, VRRP, and GLBP. In the CCNA level, we have to discuss only HSRP. Now, HSRP is Hot Standby Routing Protocol. VRRP is Virtual Router Redundancy Protocol. GLBP is Gateway Load Balancing Protocol. So need of the default gateway, because we have to forward the traffic to the external world. That's why we need a default gateway. And default gateway redundancy, when we have multiple service provider, if one service provider goes down, then we have to automatically switch over the traffic to the another secondary ISP. FHRP, when you configure FHRP, any FHRP protocol like HSRP, VRRP, or GLBP, they will create a virtual router, and that virtual router is having a IP address from the same internal subnet. So whatever IP address you will assign to the virtual router, that will work as a default gateway for your internal clients. Okay. Now when you configure the virtual router, in that case you are giving priority to your ISP. Higher the priority of the ISP, the route will be more reliable. So let's assume on this router I'm giving priority 150, and on this router I'm giving priority 145. So my traffic will firstly move to the virtual router. Virtual router will keep information like, okay, who is having the higher priority. So virtual router will forward that packet or that traffic to the higher priority router, and from that higher priority router the traffic will move to the external world. If that higher priority goes down, then within 3 seconds, let's say if you configure HSRP, so within 3 seconds, this virtual router will get to know, okay, this router is down. So it will automatically switch over traffic to the secondary service provider. Okay. Understanding HSRP. HSRP is Hot Standby Routing Protocol. HSRP define a group of router. In the group of router, one router will behave as an active router and one will be the standby. Virtual IP and MAC addresses are shared between the two routers. So whatever IP address you will configure for the virtual router, that will be the shared IP between the active and standby router. To verify HSRP state, there is a command show standby. We'll see that command. HSRP is a Cisco proprietary and VRRP is a open standard protocol. Okay, now understanding the HSRP. When you configure HSRP, one router will behave as an active router and one router will behave as a standby router. Okay. So before that, let's discuss about the basic properties of HSRP, and then we'll discuss that how the packet flow. In FHRP, we have three protocols. So one protocol is HSRP. HSRP is hot standby routing protocol. First thing, HSRP is Cisco proprietary. Means this protocol only work with the Cisco routers or Cisco layer 3 switches. One router will be active and other will be standby.
Does this work on the ASA too?
Yeah. In ASA2, ASA also this this redundancy will work.
Thank you.
But when all protocol will work there. HSRP having two version. HSRP version 1 use multicast address .224.0.0.2, and if you have HSRP version 2, that will use multicast address 224.0.0.102. HSRP use UDP port 1985. HSRP send hello packet in 3 seconds and hold down is 10 seconds. HSRP work on priority basis. Higher priority route will be prefer. Next. In HSRP, preemption is by default disabled. What is preemption? We will discuss that thing practically. HSRP virtual MAC. When you configure HSRP, a virtual MAC address will generate, and that virtual MAC address will be this x-axis group number. So let's say if you define HSRP group 1, so it will become AC01. So these are the property of HSRP. By default, no load balance in HSRP. But if you want, you can configure multiple group and then you can achieve the load balancing. So let's say we have these two service provider. This is my internet router, ISP1, ISP2. This is my LAN. So right now, if you put default gateway of ISP1, which is .1, so every time your traffic will move to the ISP1 and ISP1 will forward that traffic to the external world. If the traffic is, if the gateway is 2, in that case, the traffic is forwarded to the ISP2 and ISP2 will forward that traffic to the external world. But again, if we are putting static IP address of the ISP, in that case, we cannot achieve the redundancy. So to achieve the redundancy, you have to configure these protocol HSRP, VRRP or GLBP. So here I'm talking about HSRP. So when you configure HSRP, one virtual router will create. This virtual router is having a IP address and a virtual MAC address. When you configure HSRP, you have to give priority to the ISP. So let's say here I am giving priority 150 and here I am giving priority 145. This virtual router is having a IP address, let's say dot 100. So dot 100 will be the default gateway. So default gateway will be 192.168.1.100. This virtual IP. So this virtual IP have the information of both the ISPs. And this virtual router will send hello packet in every 3 seconds to both the ISPs to just check out the ISP is active or not, the interface is active or not. So when this client will send any traffic, so firstly traffic will move to the virtual router. Virtual router will check which ISP is having the higher priority. So based on the priority, the traffic will move to the ISP and ISP to the external world. Let us assume this link goes down. So what will happen? Traffic will move to the virtual router. Virtual router within 3 seconds it will get to know, okay, this link is down. So that means this ISP is down. So it will automatically forward the traffic to the ISP number 2 and ISP number 2 will be forwarding that traffic to the external world. So in this way we can achieve the redundancy. Any question? Okay. If you don't have any question, let me ask one question. Tell me one thing. If this link goes down, what will happen? HSRP will work or not?
I think it'll still do what it was doing because it doesn't know.
If this external connectivity is down, the ISP will work or not? HSRP will work or not?
I think the traffic would not work.
Traffic will not work, right? That's correct. So if this link goes down, then HSRP is working fine. There is no problem into the HSRP. HSRP will work in this internal network. And this virtual router is telling this ISP is up because this virtual router is monitoring this interface and this interface. So these two interfaces are up and it will tell HSRP is up. So every time it will forward that traffic to the ISP1, but the connectivity with ISP1 to the external world, that is down. So in that case, your traffic will drop here. So we have a solution for that. We can track this interface. Track interface means we can implement a policy like this. If this link is up, then only forward traffic to the external world. And we can implement like this. If this link goes down, then decrease priority by default 10. Whatever value you want to put here, you can put. So by default is 10. If this link goes down, so it will decrease priority 10. So priority 10, if it decrease from the original one, how much you will get? 140. So it will configure its priority as a 140 and here we have 140 45, so traffic will again start moving towards ISP2. Clear now?
Yes.
Any question? So we have to implement this thing. Anyone implement this thing in real network in your company? Have you seen this type of scenario?
I've worked with redundant ISPs, but we've always just manually switched over when one link went down.
You are doing manually? Strange. Approximate 99% companies are implementing this thing because it's automatically provide redundancy. No manual switching of the ISP. So in CCNA level, we have to discuss only HSRP. So let me just give the basic information of VRRP and GLBP, but we will not implement practically VRRP and GLBP. VRRP, it's Virtual Router Redundancy Protocol. It's open standard. One router will be master and other will be backup. It use multicast address. Two two 4.0.0.18 and UDP port number 112. Hello interval 1 second. Again, it work on priority basis. Virtual MAC. Again, this access is group number. So whatever group number, VRRP group number you are putting, that value will come here. By default, no load balance. But if you want load balancing, then manually you can configure. GLBP, Gateway Load Balancing Protocol. Sorry. GLBP is again Cisco proprietary. It use multicast IP two two 4.0.0.102 and UDP port 3332. Hello is 3 second and hold down is 10 second. It provide load balance. One router will be AVG, active virtual gateway, and rest will be AVF, active virtual forwarder. Virtual MAC will be this is the group number. Now, this GLBP working is little bit different. For example, you have 4 ISP. 1, 2, 3, 4. Again, it work on the priority basis. Let's say here we have 150, 140, 130, 120. So the router which is having the higher priority, that router will become AVG, active virtual gateway. That will be the master basically. So whenever these user will send traffic, so traffic will firstly move to, okay, one will become AVG and rest router will become AVF. AVF forwarder. So when this traffic will forward the traffic, so firstly the traffic will go to the AVG. Now AVG is having that information which other ISP are free, who is not sending any traffic. So let's say ISP2. So AVG forward this request to the ISP2 and ISP2 will forward that request to the external world. Let's say new request came, that again will go to the ISP1 and ISP1 is checking ISP2 is busy right now for sending the traffic. and ISP3 is free. So ISP1 AVG will forward that request to ISP3 and ISP3 will forward that request to the external world. Same way, if ISP2 and ISP3 are busy, so AVG will forward that request to the ISP4 and ISP4 will sending that traffic to the external world. Let's say all ISP are busy for sending the traffic and some more traffic came. Right now it sees, okay, all the ISPs are busy, so I can forward traffic through myself. So this is the working of GLBP. Any question? So in this way it provides load balance. It can utilize all the service provider. But in case of HSRP and VRRP, at a time only one ISP will be active and the another will be to the standby. But here my all ISPs are in used. Yes, any question in the theory part? Can we move? I'm just verifying this lab can be done in packet tracer or not. Just give me a second. Okay, it will work. So you have to make a lab in your packet tracer and everyone will do this lab. So I'm making the topology and you have to make the same topology and use this router 2911. So you need 3 routers in this lab. One switch you can take 2950 or 2960. That will be the connectivity. Inside the network, you have to take 192.168.1.0/24 network. On this service provider, IP will be 1. Here will be .2. Here I will take network, let's say 12. On this link 13. These will be the public IP. And let's assume on this router we have a server 200.200. Let's say 100. Just draw this lab and when it's done, then let me know. Then I will show you the configuration task. Everyone is having packet tracer right now?
I don't have it. I couldn't get it to install right.
Subnet mask and default gateway, I will use .100, and that .100 will be IP address of that virtual router. Let's 104. Okay. So firstly, you have to configure this service provider 1. Here I will configure priority 150, and here I will configure 140, 145. So this is my ISP1. So I'm changing the host name, ISP1. Now on the interface gigabit Ethernet 0x0, we have to assign IP address 192.168.1.1, 255.255, and no shut. Same way, interface gigabit Ethernet 0x1, IP address, let's say 12.0.0.1, so I run these command here. On ISP2, the configuration will be, here there will be a change, .2, and here will be .13.1. So all configuration is done here. Next task, you have to configure this router. Any name you can give here. You can create a loopback interface loopback 0, and on the interface you can define this 200 IP. Loopback interface is the virtual interface which will behave as a physical interface. Okay, so that will be the configuration, the basic IP address configuration. You can say it's my step number 1. Now, before implementing HSRP or VRRP, make sure there is a end-to-end reachability. For end-to-end reachability, we have to use any routing protocol, RIP, IGRP, OSPF, any routing protocol you can use to achieve the end-to-end reachability. So here I'm using EIGRP protocol. Step 2, run any routing protocol. So on ISP1, router EIGRP 100. Then on network, you have to define one network is 12. Another one is 192.168.1.0. If you are on ISP2, in that case, you have to advertise 13 and this 192. So it formed the adjacency with the ISP1. Now we have to configure here on INT router. On INT, we have to configure 13. We have to configure 12. and that 200 network. So everything is working fine. So just to test the connectivity, let's say here I'm giving 192.168.1.1. Let's say I'm giving service provider one IP address, and I will try to communicate with that 200 network. I'm able to communicate. So that means my traffic is reaching to that 200 network. So end-to-end reachability is there. Now the last step, we have to configure HSRP. In HSRP configuration, HSRP you have to configure on ISP1 and ISP2. So when you configure on HSRP on ISP1, then firstly you have to go to the interface gigabit Ethernet 0 by 0, the interface which is connected to your LAN. Then under this, first command will be standby. After standby, you have to give a group number, any group number you can take. So let's say here I'm taking 5. Then you can take group number till 4095. So here I'm taking 5. Then IP. That IP will be the virtual router IP address. So for example, here I'm taking 192.168.1.100. Next command will be standby priority. Standby group number priority. Here I am giving priority 150. Next command will be preempt. Same command you have to enter on ISP number 2. You have to just change the priority. So standby IP will be same. You have to change priority, let's say 145, and preemption you have to enable. Clear this configuration. Now you have to Now my default gateway is 100. If you try to communicate again 200.200.200.100, I'm able to communicate. Let's verify my traffic is going through which service provider. So for that we have a command tracert. So it is going to ISP1 and ISP1 to destination. So ISP1 is forwarding that traffic to the destination. Let's say if on this ISP, if I shut down that interface, so if I shut down this interface, you can see still I am able to communicate. And you can see it automatically switch over the traffic to the ISP number 2. Now we enter one command, standby, group number, then preemption. Now the meaning of preemption is currently my traffic is going through ISP2. In the meanwhile, let's say this ISP1 is up. So what will happen? It will again automatically switch over secondary to primary once again. This is the meaning of preempt. So we are waiting only for this, that port is up. Okay. So you can see it switch over the state. Standby to active once again. There is a command show standby. So you can see your state is active. This is your virtual IP address. Virtual MAC address is this. See the last group number. Here the virtual MAC address is different. Why different? Because in the slide I write HSRP version 1 virtual MAC address. So currently it is version 2 by default in the new iOS. That's why the version is the virtual MAC is changed. Here you can see the priority is 150, which is configured. Standby router is unknown. It will identify okay after a few minutes. Priority is 150. This. There is one more command, show standby brief. So in show standby brief, it is giving the information. You configure HSRP on this interface. You configure group number 5. You configure priority 150. Capital P means preemption is enabled. State is active means your router ISP1 is active right now. A standby, this router is standby, and this is the virtual IP address. If you enter the same command on ISP2, show standby brief. So it is showing on ISP2 we configure priority 145. The state is standby, and who is active? Active is 192.1.1. Clear this thing? Any question in the configuration? And let's see that part. If this link goes down, the upper one, so you can track this interface gigabit Ethernet. So there is a command, standby number track gigabit Ethernet 0/1 and enter. So by default, it will decrease the priority 10 if that particular link goes down. So through this command, we are tracking this interface also with HSRP.
Hey, Rakesh, we have like 5 minutes that we can see these commands real quick and implement them into our routers? I kind of fell
Yeah,
behind.
sure. I will share that complete picture with you. Okay.
Thank you.
Now, so let's say if this link goes down, so I'm manually shut down this interface gig 0/1 shut. Let's see the effect. What will happen? It should give a HSRP message. Show standby. You can see now. It changed state to standby. Why standby? Show standby brief. We configured 150, but due to that interface goes down, the priority will be 140 because it decreased -10 from the actual configured priority. If you run here one more command, show standby. So in this, it will give you the information. Currently priority is 140, but configured is 150. The track interface is this and the state is down, and due to this decrement priority 10. Clear this thing? If again that interface is up, no shut. Within 3 seconds, that virtual router will get to know, okay, again that interface is up. So again that router will be the active. Next topic is switch port security. So switch port security is a security feature on switch to bind a particular MAC address on a particular port. For example, this is my switch. This is a MAC address, let's say AAA. And if you want to bind this port only for this MAC address, so that if any other user try to connect his PC to that particular port, that port will not work. So we are binding or we are reserving this interface for the particular laptop or particular desktop. Switch port security, work on access ports. where my end users are connecting. What is the configuration now? So firstly, you have to enter into the switch interface. The first command will be switch port mode access. That port must be access port. Then next command will be switch port -security. This command will enable the port security feature on the interface. Next command will be switch port -security maximum, let's say 1. Means you want to allow only one MAC address. If you are giving 2, in that case you have to put 2 MAC address manually. Next command, switch port -security MAC-address, and you have to give MAC address like this way. In this format. If you are giving maximum 2, then you have to enter this command once again, switch port security MAC address, and the MAC address is like BBBB. So you are allowing this particular MAC address. Now you have to define in action if someone else is connecting to this port. Switch port -security violation. In violation, you can define 3 action. One action will be, the default one is the shutdown. Either you can define shutdown, you can define restrict, you can define protect. So default one is shutdown. If the port violation is shut down and if some other user is connecting to that port, so that port will go to the error disable state.
Just to clarify, does that mean that if a violation were to occur with the default action of shutdown, that the only way to get the port to re-enable would be to manually go in and type in no shut?
Yeah, I'm coming to that point. So violation will be either shutdown. In shutdown, if violation happen, port will go to error disable state. In error disable state, your port will not work. If you want to recover that port, then there is 2 method. One is the manual method, one is the automatic method. We'll discuss those 2 methods. So if the port violation is shut down, and if the violation happens, then port will go to the error disable state. And this is the default violation. And it will generate a alert. Generate a alert message to the syslog server or any monitoring server. If you are defining protect, or let's say first restrict. In the restrict, if violation happen, packet will drop. And it make a log entry and generate a violation. Protect. This will work with sticky mode. Sticky, in switch port security, we have a command switch port security MAC address, and after that we are defining a MAC address. But let's say if we are not defining the MAC address, we can define their switch port security MAC address sticky. Sticky means first come first. So whatever first user will connect to that port, that user MAC address will automatically stick with particular that port. So in that case, there is no need to define the particular MAC address of the PC. So if the mode is sticky, then you can define the protect action. In that protect action, if violation happen, then drop the packet. But no log entry. But there will be no log entry into the syslog server. No. Array disable recovery. If a port is in array disable state, then you have two methods to recover that port state. Method 1. Let's say my port is switch fast Ethernet 0x1. So let's assume this port is into array disable state. So manually you have to put first shut down and then you have to put no shut. Then only that port will work. Method number 2. You can define array disable recovery, cause if you know the reason, then you can write the particular reason. For example, if the port is going into array disable state due to the port security, so you can define here P secure violation. If the port is going due to the BPDU guard, so you can write here cause BPDU guard. But let's say if you don't know the reason, you can put it here simply all. And then you can define the interval. Array disable recovery interval, let's say 30. That 30 is into the seconds. This timer is into the second. So after 30 seconds, that port will automatically try to recover from the error disable state. So any question on this topic now? Anyone? So for this port security, there is a lab. Discovery number 37. Try to complete this discovery.
Rakesh, I'm getting the same thing. I'm getting login failure.
Me as well.
Everyone is getting login failure.
I am. Chris.
Let me see. Okay. Everyone is getting this login failure. Where is getting this thing? Andrew? Chris?
Yes, I'm still getting login failure.
Same with me. It's Chris.
Okay. Let me check. Okay, we have this switch. And we have these two PC. This PC is having MAC address. This MAC address. Let's say here I am assigning IP address 10.0.1. This PC is having MAC address and IP address is this. So firstly, take two PCs and make sure what is the MAC address of that particular device. To verify MAC address, you can go to the PC config and in the interface fast Ethernet 0x0. In that, it will show you the MAC address. So firstly, note down the MAC address of the two devices. If it is done, then let me know.
Good here.
Okay. So let's move. So if you see, the MAC address is different on both the systems. So what I want to reserve this MAC address on fast Ethernet 0x1. So for that, you have to implement switch port security. So you have to enter into the switch port. Then the first command will be switch port mode access. So the port should be into access mode. The next command will be switch port security. This command will enable the port security on that interface. Next command, switch port security maximum 1. Here you can define 1, 2, 3, 4, 5. So if you are increasing more than 1, then manually you have to write the particular MAC address information. Next command, switch port security MAC-address, and either you can define here particular MAC address or you can define here sticky. You can see now. If you put sticky, in that case, the PC which is connecting first, that MAC address will be automatically stick with that port security. Here I want a particular MAC address, and that MAC address is this. So I can just simply copy this and like this. So MAC address and the particular MAC address. Enter. After that, you have to define the action. Switch port security, violation. If you type here question mark, you are getting 3 options: protect, restrict, and shut down. So I'm putting here shut down. So if you want to note down, these are the commands. Any question into the configuration task? Yes, anyone?
I'm good.
See, I'm not putting that MAC address custom. Everything is there. So if you take any PC, every node is having automatically getting a different MAC address. Okay, let's verify this thing now. If I'm connecting this PC, everything will work fine. Because we give this MAC address. So it is taking these 30 seconds, listening to learning, learning to forwarding due to the STP. If you want to discard this thing, what we can do? Anyone? If you want to discard 30 seconds of STP timer on the host port, what command we can enter here?
That's
Anyone?
the error disable command?
Sorry?
Error disable?
No, that is for recovery of error disable.
Okay.
If you remember yesterday, we discussed about port fast, spanning tree port fast. So inside that you can define interface fast Ethernet 0x1, spanning tree port fast. So this spanning tree port fast will not wait for those 30 seconds. It will discard the spanning tree. So this port is working fine because we map this MAC address here. But let's say apart from this PC, if I'm connecting this server PC, which is having a different MAC address. So it is showing once again the implement on this switch once again. Font size is okay. Should I increase the font size? Okay. So firstly, interface fast Ethernet 0x1. First command is switch port mode access, switch port port security, switch port port security maximum 1, switch port port security MAC address, and my MAC address is 00.0B.A8.3D98. After that, switch port port security violation shutdown and exit. So these are the command to enable the switch port security. Now let's verify.
I have a quick question for you before you move on.
Yes.
If you forgot to add the violation activity and then you exited, can you just go back in and what steps do you have to do to get back into the same point to add that?
You are talking about the violation action, right?
Yeah, because I exited after I connected the MAC address before, and so I just went into I think I went into the configuration of the interface, and then I just typed switch port security violation shutdown.
Okay.
Is that okay?
Yeah.
Yeah. Okay.
So here the interface is connected fine. So there is a command show interface status. That command is not working in our previous version. So here if you see, it is showing 0x1 is connected. Okay. Where is the delete option here? Actually, first time I installed this new version, so I don't know where are the options. So we have to find out. Are you getting somewhere delete option? How we have to delete physical? This one. So now if I connect this PC to the 0x1, let's see what will happen. It is showing change state to down. Correct. This result we want. Here we want one more message, error disable. The port is into error disable. It's not implementing that thing. In HSRP, we track a particular interface, right? But that feature belongs to HSRP only. Suppose you are using static routing on both the service provider, and if you want to track that outbound connectivity, so in that case, what you can apply the service level agreement. Means this is our internal network. This is internet router. This is my ISP. This configuration you can do with the help of HSRP. You can track the internal connectivity. But if you want to put a policy, let's say you are implementing a PBR. In that PBR, you are telling this ISP1 is my primary ISP. In that case, you can track this interface with the help of IPSLA. In IPSLA, what you can do, you can send a dummy hello packet, like your echo message and reply, request and reply. So you can implement this thing. If you are getting echo request and reply, means this connectivity is working fine. then send the traffic on this link. If you are not receiving echo request and echo reply, so it will tell this IPSLA is down. So if IPSLA is down, in that case, forward that traffic to this alternate path. So IPSLA is basically tracking the outbound connectivity. And it's not like that. Maybe if you want to track from here to this connectivity, you can track that thing. Any source to any destination connectivity you can track with the help of IPSLA. So in that case, they are showing PC1 and a server is there. Between this connectivity, there is a layer 3 switch, then there is a router, there is a R2 router, and then we have a server. So we have to verify the connectivity. So IPSLA can use ICMP echo request and response packet to test the availability. If you are sending any traffic from headquarter to the branch, so there can be multiple devices between them. So you can create a IPSLA, and in that IPSLA you can track this source to this destination. And that tracking we can do with the help of ICMP echo request reply. So how we have to implement this IPSLA? So first thing, on the router or on multi-layer switch, you have to define IPSLA and any SLA number, for example, like 1, 2, 3, any number. Then you have to define ICMP echo destination address. Destination address, for example, in that case, here I have 10.0.0.1 and here I have 20.0.0.1. So destination IP address 20.0.0.10. You have to give destination. Then you have to define the life when this IPSLA will start. So you can define IPSLA, SLA number, whatever number you give here, let's say 5, life, let's say you can give forever, start time, let's say now. So on R1 you are creating IPSLA. IPSLA, any SLA number, let's say 5. Inside the SLA you have to define ICMP echo. And destination means you want to track the connectivity from here to here. So you have to give this destination. Then you have lifetime IPSLA schedule. Then after that you have to give SLA number, SLA number, let's say 5. Then life, you can define life is forever. Then you have to define start time, and you can define it will start now, and you can define the particular time period also. Inside that you can define a command frequency, means in how much time it will send ICMP echo packet. So frequency 10 means it will send in every 10 seconds. IPSLA schedule 1 live forever. Start time now. That IPSLA will work. Then show IPSLA configuration. It will tell what configuration you enter there. Show IPSLA statics. It will tell you how many packets are hit on that particular IPSLA. Configuration, it will show you like this way, statics. You can track this connectivity with the trace route command. This is the ARP request. Okay, so this thing is the IPSLA configuration. One more thing, if you read CCNP route or advanced routing part, then we can call this IPSLA into the policies also. For example, like if you implement PBR, policy based routing, so in that policy based routing you can call your IPSLA. You can make different policies with the help of IPSLA. Now we have span. Span is switch port analyzer. Switch port analyzer. Let's say if you want to monitor a particular port on the switch. Let's say these are the two users which is connected on 0x1 and 0x2. Here we have, let's say 0x24. You want to track the traffic of PC1 and PC2, means what kind of traffic they are sending through that particular port and what kind of traffic they are receiving on that particular port. So you can track that particular traffic with the help of span. Used to track interface traffic. Incoming and outgoing both. So for to monitor that traffic, you need a separate PC, which will be your monitor PC. In that monitor PC, operating system can be anything, but you need third-party application, for example, which can capture the packet. For example, like Wireshark, Ethereal, any software which can capture the packet from the network. So once you install the packet tracer on this, install the Wireshark on this PC, that PC will work as a destination for the monitored traffic. So when you implement the span, these two ports will be my source port, and you will define this interface as a destination port. So span feature allow you to instruct a switch to send a copy of the packet that sees on the one port to the another port on the same switch. In span, source and destination will be on same switch. We have one more advanced concept, RSpan, remote span. In the remote span, source will be on any switch and destination will be on different switch. So in this, they are showing whatever traffic is coming to this Ethernet 0x1 and going out through 0x2, send a copy to this sniffing PC which contain the Wireshark. What is the configuration? Monitor session, any session number, for example like 1, then you have to define source interface and the interface. So configuration will be like this. Zero by 1, 0x2. This is my 0x24 Wireshark. So in the switch you can define monitor session, any session number, source interface, and you can define like fast Ethernet 0x1. And after that you can define both. Both means incoming and outgoing traffic. If you want to monitor only the receiving traffic, you can type here RX, or you can define here TX. TX transmission, RX receiving. Same command you can type for session number will be same. Source interface, FA 0x2, again both. Then you have to give the destination information. Monitor session, one destination. Fast Ethernet 0x24. That will be the configuration. So it will forward the traffic to this packet sniffing. Same configuration. So this same lab will be in the online rack. So we can do this discovery also. IPv4 ACL we already done. Any confusion till now? Any question into the span?
Seems pretty simple to me.
Okay. Through span, you can monitor the traffic of the particular port, as well as you can define this span for particular VLAN also. Okay. So if in the particular VLAN there are 10 interfaces, it will capture the traffic of all those 10 interfaces. All the switching topic is over now. Okay. Next topic we'll do WAN technology. And in the WAN technology, we have to discuss the basic of WAN technology, and we have to implement the GRE tunnel. Anyone feeling hungry?
Oh yeah.
Because if I start the topic again, then we have to wait 1 more hour. So we'll take break now or after 1 hour. Okay. Yes, anyone? What is lease line?
That's a line that you pay for from the service provider that provides you a direct connection between your two sites.
Right. So lease line is basically permanent connection between the two sites. In this lease line, the bandwidth is fixed, and this lease line is available 24/7. You have to pay for that lease line. The cost is very high as comparison to other technology, and it is not scalable. Means lease line is a point-to-point connection between the two sites. If your network is growing and you have multiple sites, for each and every site you have to purchase a separate lease line. So normally we are using lease line as a backup link. And in the lease line, our path is fixed. Next is frame relay. Frame relay is again a WAN technology. It's a layer 2 protocol. Why layer 2? Because it uses the layer 2 addresses for forwarding the traffic. In frame relay, DLCI numbers are used. Those DLCI number are like your MAC address, layer 2 addresses. And those DLCI number is provided by yes, everyone is able to see the screen.
Yes.
Verity, have you any issue getting this?
Well, you're usually, it sounds like you're writing about the lease line and then maybe switching to another slide for a frame relay as you've been doing. Am I missing it? Just kind of what you were doing, but I could be wrong.
Okay.
Oh, thank you. I just wanted to make sure that my screen wasn't frozen. I'm getting all the information. I just didn't know if I was having technical issues. So. Okay. Don't worry about that. I just need to know. All right. Thank you.
So in the frame relay, basically, the connectivity is like this way. Let's say this is your HQ. And we have branch 1, branch 2. This will be the physical connectivity with the service provider. Now, frame relay is running here. So for the frame relay, ISP use special switches. Those switches are known as frame relay switch. This switch will not understand the MAC address. They will understand DLCI number. And these DLCI number are provided by the service provider. So let's say if you have two sites. So to connect two sites, you purchase two DLCI number from the service provider. So if you map 100 to 101, so this link will be up. If you map 200 to 201, this link will be up. So inside this frame relay cloud, this logical connection is known as virtual circuit. Frame relay is now obsolete technology. No one is using right now frame relay because it is a slower technology. Next is MPLS. MPLS is multi-protocol label switching. Now, in MPLS, traffic is forwarded based on the labels. This is my MPLS cloud. Let us assume this is customer A, customer 1, customer 2, customer 1, customer 2. This is my ISP. This is complete ISP network. So in MPLS, this router is known as PE, provider edge router. And these routers will be CE, customer edge router. Means the router which is connected on ISP premises, that router is known as provider edge, and the router which is in your own premises, that is known as customer edge. And here is your LAN. Inside this MPLS, these routers are known as provider routers. So to implement MPLS, first thing you have to run any IGP protocol inside this network. That can be any protocol like OSPF, which will provide this ISP to this ISP connectivity just for the reachability purpose. So in MPLS, this customer can use 10.0.0.0. network. This can also use 10.0. network because this is a private network, and private network anyone can use. So when you are taking MPLS connectivity, in MPLS this ISP will create VRF, virtual router forwarding. So it will create a VRF A, and A, B, C are the name. VRF B. So in that VRF, this VRF is for this customer, this VRF is for this customer. So the point is, on this router, there are two kind of table. One is routing table, and one is the VRF table. VRF table for each and every customer, just to segregate the route of the customer. When the traffic reach to this ISP will put label. Label can be any, like 10, 20, 30, 40, 50. So when the traffic reach to this service provider, it will add label. Every router will add labels in this MPLS domain, and they will forward the traffic based on labels. They will not look up what is inside the IP packet, what is the source and what is the destination IP. No, they will just look up label, what is incoming label and what is outgoing label. So based on the incoming and outgoing label, they are forwarding the traffic. So it reduces the lookup time of packet. Because if you are not using MPLS, in that case, what will happen? Routing is happening on every router. Every router will check the IP packet, and based on the source and destination information, it will forward the packet to the next hop. But here into the MPLS, the traffic is forwarded based on the label. It will not look up into the IP packet. Next is VPN. Again into the VPN provide the connectivity between the two sites. We have lots of type of VPN. Site-to-site VPN is there, remote access VPN is there. Under the remote access VPN, we have clientful VPN, clientless VPN, SSL VPN is there, Flex VPN is there. So we have lots of type of VPN. Now, under the VPN, we have a type of VPN GRE. GRE is a kind of VPN, generic routing encapsulation. GRE is point to point. GRE is Cisco proprietary, developed by Cisco. GRE traffic is not encrypted by default. If you want encryption, if you want to secure the data, you have to implement GRE with IPSec. GRE work on port number 47. It can encapsulate any layer 3 information. It can encapsulate any layer 3 information. Let's say we have site A and site B. These are in two different cities. This is site A, site B. Now I want to connect these two sites with the help of GRE tunnel. So in the case of GRE, between these two sites, or you can say two service provider, GRE tunnel will create. So once the GRE tunnel is working fine, then my traffic will move like this way. It will reach to the ISP, ISP to the GRE tunnel, and GRE tunnel to the destination. For this network, my traffic is transparent. So whatever routers are there on the internet, they will not look inside my packet, because once they get, the information will be like this. This is my data. That data is encapsulated with GRE tunnel header. So we have to see this configuration, how the GRE is encapsulating my traffic. So for implementing GRE, because I'm not sure like GRE will work in the packet tracer or not. So for GRE lab, I'm using GNS3. Okay, just tell me the name of 2 cities in your country. Only 3 characters for one city. Anyone?
Lancaster.
So first 3 characters. Let's say Anne. Another one.
Denver.
Alice.
Sorry.
Denver.
So let's assume this is my branch 1. This is my branch 2. So let's say in my branch 1, we have a network, private network 192.168.1.0/24. And in branch 2, we have a network 192.168.2.0/24. Between this branch 2, this Manchester router, we have a network, let's say 12 dot network. Here we have 23. Here we have 34. And here we have 45. Clear this thing? So if I want to communicate this 192.168.1.0 to 192.168.2.0, so till now we done lots of routing protocol, RIP, IGRP, OSPF. You can implement that routing and your communication is done. But this is the external world, internet. If you want to implement RIP, IGRP, OSPF, in that case you have to enable the RIP, IGRP, OSPF on this internet world also. And if you do dynamic routing with the help of service provider, in that case, what will happen? Your internal network information will be on the ISP side, and it's not good for your security, because if external user knows about each and everything regarding your network, he can do anything because he has the reachability to enter in your network. So when we are connecting the two sites over the internet, then we are using some kind of VPN. So GRE tunnel is a kind of VPN. Like if you see the definition of VPN is to connect two private network or two branches over the public network. So this is my public network. So here we have to implement GRE. So when you talk about GRE tunnel, GRE is a point-to-point tunnel from Manchester to Denver. Every GRE tunnel is having a required different IP subnet. So let's suppose inside the GRE tunnel, we have a subnet 192.168.100.0. This is the GRE subnet. So when you are creating the GRE tunnel or any kind of tunnel, then every tunnel is having a source IP address and a destination IP address. So let's say on Manchester router we have source .1 and here we have .2. This is the topology for GRE. Anyone having any issue in the topology? Okay. Now I'm going to implement the configuration. clear this thing?
Yes, I'm doing it along with you. So
Okay. So you are following the same topology, right?
yes, same IP address and everything. I just got a different model of router. I got a 7200 router, but
That's not an issue. Okay. So the devices are started. Okay, firstly, I'm configuring branch 1. So first step is just to configure the IP addressing. Okay, font size is okay, or should I increase the font size? Where is that? Change setting. I think so. Now it's okay. Okay. So on fast Ethernet 0 by 0, we have IP address 12.0.0.1. No shut, exit. We are creating a loopback interface for this LAN. So on branch, I run these commands. Everyone is clear on this part? Next, Manchester router. Zero by zero. IP address will be 12.2. No shut, exit. On 0 by 1, 23.1. Any confusion? Then we have this internet router. Clear this part? And then last router, branch 2. Okay, now we have to configure .1 IP address there. .2 already configured. You can see .2 is already configured. We have to configure .1 here. So I have to run these commands on branch 2. Any confusion in IP addressing? Okay. Now we are going to make tunnel between Manchester to Denver. So to configure any kind of tunnel, there must be a end-to-end reachability. So if I go to the Manchester router, if I try to ping, let's say do ping, the IP address is 34.0.0.1. I am unable to communicate. So if there is no reachability, then we cannot make any kind of tunnel. So just to provide a reachability, I am creating a default route here. And same way on the Denver router.
I don't have GRE. I'm doing this in Packet Tracer. And when I go do tunnel source IP address, I get invalid input detected at the start of the address. Do you get that, Rakesh? Did you get my message? Is anyone else getting any audio? Because
I was about to ask the same thing. I'm not
Rakesh isn't hearing me.
I can hear both of you. I can't hear him, I don't think.
Yeah, I can't hear Rakesh, and he's not hearing me.
Still nothing from Rakesh?
No, I've sent him several private messages and he's not responding to that either.
I can't hear him either.
These will be the configuration of IPs. Once the IP address configuration is done, then let me know.
What's up, buddy?
So next task is we have to make reachability between Manchester to the Denver router. So for that you have to create a default route. So IP route Once this is done, then let me know. Okay. Next, we have to make the GRE tunnel. So interface tunnel 0, then tunnel IP address, then tunnel source. So this packet tracer is not supporting the IP command. So here you can define tunnel source, gigabit Ethernet, 0 by 1, your outgoing interface name. Same way, tunnel source destination. In destination, you have facility to provide the IP address. So 34.0.0.1. Then tunnel mode.
Oh man, yeah, it was sometime this week in the afternoon. Brian, you hopefully I can finish up this course around 3:30, and then I can head your way. I'm glad you called back. I thought about it completely, but yeah, yeah, we agree. So, I'll try to shoot. I'll try to shoot your way to, this afternoon, and then I will. I start terminal.
Okay. So next step, we have to implement the routing part. So router HRP 100, network 192.168.1.0.
Okay, bitch.
this is the full configuration. Once you're done with the configuration, these two commands for the verification. After that, see the output and you will get your verification. Yes.
It's possible to paste the data without it running automatically. Because I actually pasted the data, but it like added the wrong IP address.
Hold on. Share your screen.
So I copied it from here. Well, I added the tunnel to the Denver router, but it wasn't showing right. So then I realized I forgot this step here to add it to the Manchester router. But like I said, totally added the wrong IP address.
100.1.
Like everything.
No, configuration is correct.
Oh no, because because I pasted. Oh, thank God. Well, let's say I did that on accident. Is there an undo everything you just did button?
Maybe. But where you are getting the error message?
No, actually, I was just thinking there was an error, but actually I was wrong.
No. This and show run this command. Show interface tunnel 0 here on the Manchester router. Use do show interface tunnel 0.
Well, that's why I thought there was an error because I wasn't using the word do and it wasn't popping up. Okay.
Okay, so first
great.
line.
Thank you for helping me.
Tunnel is up, line protocol is up. Clear?
Excellent.
And tunnel protocol and transfer to GRE IP. Yes.
But let's say, like I said, I mean, this is a big thing for me, to be able to undo. How do you undo stuff? Like if you mess up, should I be more careful entering it just because I know you can't really easily undo it, or have they like come up with a way to fix stuff like that?
And notation. Okay, this lab is done, everyone.
No, Rakesh.
Yes.
I didn't get an answer to my question. Let me just be clear.
Okay.
There's no way to undo stuff, is there?
You can like undo what you want to do. Let's say you write something. If you enter something wrongly, then undo.
Like a bunch of things wrongly, like 1, 2, 3. Like if I entered all these wrong.
No. This is not possible. Not possible. In the production environment, we can do this thing, but through SDN technology, software defined networking. Okay, that is the solution basically.
Can you repeat that? What technology?
SDN, software defined networking.
Okay.
Okay. See, here we are configuring. Let me explain that thing separately. Okay. See, we have on every device, we have 3 planes. One plane is data plane, control plane, and management plane on every device. Okay, just stop sharing. I will explain this thing.
Okay, thank you.
on every device, we have 3 planes. One is control plane, data plane, and management plane. My voice is clear, right?
So we can hear you.
Hear you loud and clear.
Okay. Control plane built by the routing protocol. So whatever information you are getting in show IP route means your routing table is your control plane. So if I show here, show IP route. This is my control plane, which is telling me how to reach to the destination. Okay, again, there is a limitation. We cannot check here the database of data plane. So this data plane, so whatever information is there into the routing table, that will copy to the data plane. This is my forwarding database. And management plane is like whatever you are configuring, telnet, SSH, HTTP, or the management port to access the device. These are the 3 plane in every device. Now, let's say when you are doing the routing part, and if you see routing table, in your routing table, you will get destination network with default gateway IP. So you can see you are getting this destination network with the default gateway IP information, correct? So once your routing table is built, the database is copied into forwarding database. In that forwarding database, what information is there? You will get destination network with exit interface information. Exit interface information. For example, here you will get, let's say 192.168.2.0. You can reach via 192.168.100.2. So this information is there into the routing table. But when this information is copied into the forwarding table, forwarding database, the information will be like this. Like this. So in the forwarding database, you will get the interface information. Okay. So this R1 is doing routing here. So once this routing is done, it will create the forwarding database. So based on the forwarding database, it will identify this path. This path is my best path. So every time when these packets are coming to this device, it will not open the complete table, complete packet. It will check just what is the outgoing interface IP, what is the outgoing interface number. So based on that, it will forward the traffic on particular that interface. So again, this reduce the lookup time, packet lookup time. Clear this thing, forwarding table, routing table. Anyone who is having issue in this? Okay. So this is into the WAN connectivity. Next, DHCP. DHCP is used to assign IP to client machine. DHCP work on UDP port number. Anyone? DHCP work on port number? '67, '68. Now, how this DHCP is working? Let's say we have these two machines. One is the DHCP server and one is the client, which is not having any IP address. So in first step, client send DHCP discover packet to the network. In the network, DHCP server is there. So server receive this DHCP discover packet and server send DHCP offer packet to client. Once client receive this DHCP offer packet, client send DHCP request to server, and in this DHCP request it is asking for the IP. Once DHCP server receive this DHCP request packet, server send DHCP ACK to client and assign IP to client. This whole process is known as DORA process. Why DORA? Discover, offer, request, acknowledgement. Anyone having any question? Okay. Next step is how we have to configure DHCP on the router. So in the DHCP configuration, we have two cases. Case 1, when DHCP in your network. For example, this is your router, switch, and this R1 is my DHCP server. This is my DHCP. Means this DHCP server exists in your internal network. Case 2, when DHCP is on remote location. For example, this is my DHCP outside my network. Clear both the cases? If we have case 2 in the remote location, in this scenario, we require DHCP helper address. So on that interface where your clients are connected, you have to define IP helper address. And the IP address of the DHCP. DHCP configuration. So Firstly, I'm describing how to configure DHCP on the router. So first command will be service space DHCP. It will enable the DHCP service. Then IP space DHCP pool and name of the pool. The next one, network. So let's say 192.168.1.0. Default hyphen router. If you want to give DNS server, if you want to define lease for 7 days, maybe some commands will not work in packet tracer. Then IP DHCP excluded address, exclude address. So whatever IP address you want to exclude from this range. So 160. This will be the configuration. So in packet tracer, everyone will make this scenario. No. First thing, you have to enable this interface which is connected to the switch, and you have to define a IP address there. Then service space DHCP, IP DHCP pool, any name of the pool, then default router, DNS server, lease command will not work here, then IP DHCP excluded address, for example 192.168.1.1 to 192.168. Let's say 1.15. This will be the configuration. Now I reserved IP address from 1.1 to 15. So clients will get IP address from the 16th. So desktop configuration DHCP. Okay, what is the problem? We haven't defined the network. So IP, DHCP, pool, ABC. Under ABC, we have to define a network. From 16. $17, 18, 19. So it will give the first come first service. So whatever IP, whatever PC will request first, it will provide IP address to that machine. Yes, anyone is having issue in this lab? Try to complete this lab fast. And once it's done, then let me know.
A strange error when I type in the IP DHCP exclude -address, and then I have my start address and my end address, and then it says invalid input detected at marker, and the marker is after all of my input.
Hold on. Share your screen.
Uh-huh.
IP DHCP excluded address. You are running this command inside the DHCP pool. That will be the configuration mode command. Exit from there. Now here you run this command.
Okay.
And your router interface is not up. You haven't assigned IP address. IP DHCP exclude address. Now the command is correct. Invalid input.
Why is my interface not up though? Oh. That's why.
No shut. No shut. No shut. No shut.
Yep. Ah.
Runs one again this DHCP exclude address command. You are using hyphen or what?
A dash.
Okay, type IP DHCP exclude and then press tab.
What the heck?
Tab. No, DHCP. You type DCHP.
Oh, you're right.
Now press tab. Now type 192.168.1.1.
I don't understand.
So previously,
That's the same.
excluded.
Oh, dead excluded address. Okay, I got it.
Okay, now, okay, Verity, you are asking like how we had to verify. So you had to go to the PC. Go to the PC, then IP configuration. You will get static. Then just click on the DHCP. Automatically, you will get IP address from your DHCP server. Clear this thing? Okay. Just give me 2 minutes. Let me take a glass of water and then we'll do the next thing. Yes, everyone completed this DHCP lab? Anyone who is pending? If you done this lab, then do one thing. Type here no IP DHCP run these two commands, I'm removing the DHCP configuration from this router. And once this configuration is removed, then take another router, connect with this router, and here the IP will be any public IP address, let's say 200.200.0/24. So on this interface, I will take .1, .2. So on R2, this time we are going to configure R2 as a DHCP server, and we'll try to provide IP address to these clients from this external DHCP server, which is not in my network. Verity, no, it doesn't matter you are connecting with the gigabit Ethernet or fast Ethernet. Make this setup ready. Once it's done, then let me know. Okay, what I'm going to do, I'm making this router as a DHCP server. So till now I just assign IP address and I am implementing routing, EIGRP routing. Because for the DHCP server must be reachable. So just to provide reachability with the help of EIGRP protocol. Once this IP addressing and routing is done, after that, same configuration, service, DHCP, IP DHCP, pool, let's say ABC, then network, 192.168.1.0. Default router. DNS server. And after that, configure DHCP service on the DHCP server. Once this task is done, then let me know.
I'm sorry, Rakesh, I missed something.
Yes.
On interface fast Ethernet 01 on the first router we configured, what's the IP? Oh, I see that. Never mind. It's 200.200.200.1, right?
On the router 1, 200, 200, 200.1,
Okay,
and
cool.
on
Got it.
DHCP server .2. Okay. Verity excluded address means we have a network 192.168.1.0 and in our network we have some servers. On the servers, let's say we assign 1.1, 1.2, 1.3 because server IP addresses are fixed IP address, static IP address. We are not giving any random IP address to the servers, because if we give the random IP address, in that case clients will not get the services from that particular server. So server IP address will be static. So we are excluding particular those IP addresses from the network, and rest of the IP address will get the client. Clear this thing? Okay. So now check, are you getting any IP address on the client machine? If you see now, once click on the static and then click on the DHCP. Anyone is getting the IP address from the DHCP server?
I'm getting a static, a self-assigned address, 169.
Right. Everyone is getting this IP address 169, which is a PIPA. So now, right now, what is happening? These clients are sending DHCP discover packet. And this DHCP discover packet is a kind of broadcast. And I already told you, router by default drop all the DHCP all the broadcast packet. So when this broadcast packet, DHCP discovery packet, is going to the router, router is not forwarding that packet to the DHCP server. If this discovery packet is not received by the DHCP server, then how it will provide the offer? So we have to allow this DHCP discover packet to go outside. So for that, on the router 1, which is connecting with your network, you have to define a IP helper address. So you have to go to the interface fast Ethernet 0x0, and there you have to define IP helper address. IP helper address and DHCP server IP. So once you provide this IP helper address, after that you are getting the IP address. Clear this thing? This thing is known as DHCP relay agent. So right now this R1 router is working as a DHCP relay agent. Any question?
I'm still getting a PIPA.
Okay. Share your screen. Okay. Go to the router. Type here show IP protocol. Do show IP protocol. See, you haven't advertised this 192 network here. You just advertised 200 network. So go to the router HSRP 100. Define network 192.168.1.0. Exit from there. Now try once again. Clear?
Beautiful, thank you.
End-to-end reachability is required. Next topic. SYSLOG server. Now SYSLOG is used for centralized logs and alert messages. SYSLOG work on UDP port number 514. SYSLOG work on security levels. We have 0 to 7 security level. So it's like that. In your data center, you have multiple devices. Let's say you are here, you are getting the console of this R1 router. If you are getting the console of this R1 router, if something happened to this router, interface goes down or some services fail, so that message you will get only on this R1 console. If something happen on R2, R3, R4, that information you will not get on R1. Okay, so that means at a time only I can connect only one device. So if something happened to my network, something happened to my data center on device number 10 or router number 10, then I will not get that information. So just to provide a centralized management, what we can do, we can configure a SYSLOG server. So this SYSLOG is a third-party application. So you can download the SYSLOG server. There are n number of vendors who are creating the SYSLOG server. For example, like Kiwi SYSLOG server is there. Cisco is creating. HP is creating. In Linux version, we have Negios tool. So right now there are lots of SYSLOG servers. So I have to configure like this. Anything happen to my device, then they should send me a alert message, log message, so that I will aware about the network, what is going to my network, and that will be helpful for the troubleshooting task. So if you want to configure SYSLOG, so on every device, you have to go to the config mode. So first command will be logging on. This command will be enable the SYSLOG service. Then next command will be logging host and whatever is the IP address. For example, like 192.168.1.100. Then you have to define what kind of messages you want. So logging trap. Here you can give 0 to 7. So let's say I'm giving here 7. 7 is for the debugging. Okay. We have emergency security level, alert, critical, error. Then we have warning, notice, notification. Then we have informational, and last one is debugging. So emergency security level is 0, alert 1, critical 2, error 3, warning 4, 5, 6, and 7. Remember these security level carefully because in your exam there will be 2 to 3 questions on this topic regarding the security level. So it's like that. If you enable, let's say 7, so it will give you all this information. If you define your trap level is 5, so it will give you 5, 4, 3, 2, 1 and 0 information. Clear this thing?
Yep.
Okay. So we are doing this lab. Everyone is having this lab right now. Correct? So go to the PC. In the PC there is a option generic. Use this server and connect this into the network. And on this PC assign a IP address. Let's say 192.168.1.100, or let's say 10. So on this server you have to assign IP address 1.10 and the default gateway will be 1.1. Clear this thing? Okay. Now go to the services. On the server, services. In the services you will get a syslog server, syslog service. So check this service is on or not. It should be on. Yes, service is on. Now I'm going to define syslog services on R1 and R2 and we'll see if something happened to the interfaces. In that case I will receive the log messages. So on both the routers define logging on, logging host 192.168.1.10, logging trap, debugging. Debugging is 7, trap 7. And same configuration on R2. Once it's done, then let me know.
Here.
Okay. So now go to the server and check syslog. Click on the syslog. Are you receiving any log messages?
No.
No. Go to the R1 and shut down this interface. Interface fast Ethernet 0/1. Shut down this. And after that, do no shut once again. Done. Now check the log messages on the syslog server. You are receiving some log messages, right? Everyone is getting now messages. No. Yes, Andrew, Tom, Chris.
I've got messages in there.
Yeah, I don't have the server on my GNS3.
See, if you want to do in GNS3, in that case, you need a complete virtual machine. And in that virtual machine, you have to install this syslog server. In GNS3, you have to do lots of things. Okay. Verity, share your screen. Have you configured syslog server on both the devices, both the routers? That's correct. Now go to your server.
Let's see. I think sorry, I was trying to mute. I think I only configured on. I only did on one router. On the
Okay,
router.
okay, on one, configure this command on R2 also.
Okay.
Okay.
Is there a way to verify it? I would like to check what I did worked.
Verification we are doing on the syslog now. Now go
Okay.
to your server machine.
Now, can you just tell me why did you do it on both routers?
See, problem can happen on any device. Okay, we have to
But
implement.
that other router is not connected. The other router is only connected to the outside world. We don't really need to log their problems, do we?
That's correct. But we have to implement syslog service on all the devices through which I am connecting. Only in that case we are getting the centralized management. Okay, go to the server and show me the IP address there. Desktop and IP address. Firstly, show me the IP address there. Okay, now go to the services. Syslog. Under the services, there is a syslog tab. Under the service syslog. Right now, you are not receiving any message. So go to the R1 router, R1, and shut down your interface gigabit Ethernet 0x1. Shut down this thing. And no shut now. Now again go to the syslog server. Click on syslog. Now you are receiving the messages.
Oh, thank you so much. That makes total sense. Appreciate that. I guess I do still have one question is, that outside router, is that actually are we connecting to it?
Connecting to?
Well, aside from the DHCP.
Uh-huh.
Okay, so we are connecting to it then, aren't we? Okay, never mind then. I answered my question.
So we done all these things, syslog. So now what is pending right now? The pending thing is IPv6 and P and HDLC, which we have to do practically. And then we have a theory part of quality of service. These things are pending, okay, which we will do tomorrow. So now I'm showing you some questions.